For this lesson and the next several lessons, we are going to be studying simultaneous equations. A simultaneous equation is where two equations or lines exist on the same xy coordinate system or graph, also known as simultaneous linear equations. Mr. Wallace calls it system of equations. I'm not familiar with that term, but as you read the book, you'll see that that is the term that he uses. Now there are three ways to solve for a simultaneous equation. The first way is with a graph. Now graph is the most work and it is also the least accurate way of doing it, but that is the system that we're going to be learning today. In the next lesson we're going to be learning substitution, which is the second way of doing this. The third way of doing this is addition. Some people call it elimination, but addition or elimination, it's the third method for solving simultaneous equations. Now we are skipping example 165. If you want to do that, you can go to the book and do that. We're going to start with example 166. And what we're going to do is we're going to solve for simultaneous equations. That means we have two lines and we're trying to find out where they cross. And all three of the systems that we use to solve simultaneous equations have their advantages and disadvantages. Graphing has the most disadvantages. However, the one advantage that it does have is it's very visual. You can see exactly what you're doing, and it's a good place to start so you can understand why we're using substitution to solve for simultaneous equations, or we're using addition to solve for simultaneous equations. And we'll get to the advantages and disadvantages of those two systems, but for today we are going to be doing graphing. Now you already know how to graph, and you know that y equals mx plus b, that m is the coefficient of x, and b is the unit values. Now b is the y-intercept, and the y-intercept for the first equation is 3, so let's mark that. There you go, and now according to the slope we're going to go down -1 and we're going to run +2. Down -1, run +2. Down -1, run +2. Or we could run +1. I'm sorry, we're going to rise +1, run -2. And we can go off in that direction. And now we have enough dots for a line. So let's take a ruler and make a line out of that. There you go, that's the solution for the first line. And I even got my arrows going out into infinity. So let's look at the next line. Again, we're going to start at the y-intercept, so we'll start at -2. And our slope is +3/4, so we're going to rise 3 and run 4. 1, 2, 3, 1, 2, 3, 4. 1, 2, 3, 1, 2, 3, 4. And then why don't we make that negative? -3 over -4, and that'll still be positive, right? -3 over -4 is positive. So let's descend 3. 1, 2, 3 in a negative direction, and let's run in a negative direction 4. 1, 2, 3, 4. Okay, and as you can see, all of those line up, and let's create a line there. There you go, we have another very nice line. And Mr. Wallace says something that makes a lot of sense. If you're reading from left to right, going downhill is negative. So if you have a negative slope, you are going to be going downhill. If you have a positive slope, you're going to be going up. You're going to be going uphill. And that's a good way to remind you that if you're working with a negative slope and somehow you end up with a positive slope, that is somehow you end up ascending when you should be descending, you'll know that your calculations are wrong, you've done something wrong, and you can go back and rework that. But the solution for this is where the lines meet. Now, where did the lines meet? They meet at 4, 1. On the x-axis, 1, 2, 3, 4. And we're going to ascend 1, 1. So the solution for the simultaneous equations here is 4, 1. And that means the point at which they meet. So as we go forward and we're asking you to solve simultaneous equations, that's what we mean. That if you drew a graph, and for most of these we're not going to be drawing a graph, but if you drew one, that is where the two lines would meet. Okay, let's solve these two simultaneous equations. As you can see, we can try to pick out some points, but that's really difficult. I don't like doing that. You know, a lot of math books do. Mr. Wallace doesn't like to do that, and neither do I. We always like to convert it into y equals mx plus b. Now you already know how to do that, so let's do that for the first equation. That's right, you already know how to convert these equations into the y equals mx plus b format. If not, you better go back and study that previous lesson, or you can even look in the book and Mr. Wallace will do that for you. So let's convert the second equation. There you go, and there's something funny going on with both of those slopes. And if you can't figure out what that is, I will walk you through that. For the first slope, we don't have a fraction, do we? No, it's 2, which is equal to what? That's right, 2 over 1. But let's start with the y-intercept of 3. And since that's positive 2 over positive 1, we're going to rise 2 and run positive 1. Rise 2, run 1, right where that 5 is. I'm not going to write on my 5. Rise 2, run 1. Rise 2, run positive 1. Or that could be negative 2 over negative 1. So let's descend 2 and run negative 1. And one more time, descend 2, run negative 1. And all those seem to line up pretty well. So let's use our ruler and put a line there. There we go. Now let's look at that second line. The second line has a y-intercept of negative 3. Let's see, 1, 2, 3, right there. And it has a slope of what? What is the coefficient of x? Since there isn't a number in front of x, what is the coefficient? It's 1. And of course, it's negative 1. So how do we turn that into a fraction? It's going to be negative 1 over 1, or 1 over negative 1, either way. But that means we're going to descend 1 and run positive 1. So let's do that. 1 and 1 and 1 and 1. And let's do that in the reverse direction. Let's rise positive 1 and run negative 1. 1 and 1 and 1 and 1 and 1 and 1. And let's make a line out of that. There you go, and we have a crossing at 2 whole points. That is, it's not going to be a fractional point. When these lines start crossing at fractions like 1.5 and 2 1/3, you can't do this accurate enough to get there. So this is going to be at 2 whole numbers, like I said, and x equals negative 2 and y equals negative 1 right there. So on the x-axis, we're running negative 2, 1, 2. On the y-axis, negative 1, 1. And that is our solution, negative 2, negative 1. Now let's look at something a little different. Now we're supposed to solve these simultaneous equations by graphing. But before we graph this, and by the way, I'm not going to graph it. Before we graph this, let's look at the slopes. Our slope here, we got 1y, right, for both of these. Our slope is 3 over 2. What's our slope here? 3 over 2. Now, what did we say in, I'm not sure it was the last lesson or the lesson before that, but where we were talking about parallel lines and perpendicular lines? What did we say about the slope? If the slope is the same, then the lines are parallel. Well, the slopes are the same. The lines will be parallel. Therefore, what is the solution to those two lines? Well, what is the solution? Remember, it's where the lines cross. Where are they going to cross? They're never going to cross. They're parallel lines. So what is the solution for this? There is no solution. So the answer is no solution. Now you can graph this out if you want. If you want to look in the book, it's been graphed out for you. But I don't see that that's necessary. And as a matter of fact, you can save yourself a lot of work by looking at the slopes first. So let's look at something else that's similar to this. Okay, this is our last problem. We have two simultaneous equations. And to figure this out, we are going to have to reduce this to y equals mx plus b. So let's change both of those. Okay, and you know how to reduce it to this format, so I'm not going to walk you through that again. And look what we have. Just like the last time, we have a slope here of 1/3, and what's our slope here? 1/3. So we have parallel lines, right? No, we do not. We do not have parallel lines because the intercept, b, is the same, -2 and -2. That means they're going to start at the same intercept and they're going to rise at the same slope. What does that mean? That means that they are the same exact line. Look at that. Y equals 1/3 x minus 2 and y equals 1/3 x minus 2. And the only way to really tell that is to change these formulas to this format. There are other ways to do it, but this is the simplest way to do it. Okay, so do we have a solution for this? Yeah, we have an infinite number of solutions because they're the same lines. They're one line right over top of the other line, so what is our solution? It's an infinite number solution. Now, it's not all real numbers. Be careful there. It's not all real numbers because y and x could be all sorts of different crazy numbers, but they have to be uniform in their relationship to one another. In any event, you just can put for a solution an infinite number of solutions. And do your homework, and we will see you next episode.